Oh, hello. Glassware. It needs to be checked before you experiment, even if it's brand new. Safety is important. The lab can be a pretty dangerous place to work. And unfortunately, well, we're all human. No matter how many years of school or work experience we have under our belts, human beings have this overwhelming desire to do the wrong thing, to take shortcuts or ignore safety precautions. So if you're new to this lab, while you're learning where the light switches are, you should also learn the safety rules.
There's a wealth of safety information you should know. You have a right to know. Your supervisor or safety instructor will provide you with in-depth training and will acquaint you with written resources. You'll learn about material safety data sheets, or MSDSs, which describe, among other things, each substance's ingredients, properties, and hazards. There's your facility's chemical hygiene plan, which is carefully designed to instruct workers on the safe use of chemicals. In fact, there's plans covering all types of hazards, including biologically infectious materials. Your instructor may show you additional information on subjects such as RECRA, TSCA, lockout-tagout, and respiratory protection. You may also be enrolled in safety courses dealing with fire extinguisher use, first aid, CPR, and other topics. Remember that your instructor and the written plans are only sources of safety information. You must choose to follow the rules. The ultimate responsibility lies with you. Plan out your experiments carefully. Assemble all the materials and MSDSs you'll need ahead of time. Remember your personal protective equipment, or PPE. Select it based on the chemicals and procedures you'll be using. Make certain you know where to find it. PPE may be stored in a central location. Each lab has rules on which areas you're required to wear protective equipment in. Required PPE is supplied by your company at no cost to you. See your supervisor. There are many types of safety eyewear, ranging from safety glasses to face shields. Wear the type or combination that's right for the job you're doing. And remember, regular street glasses are unacceptable. Lab coats are also personal protective equipment. They help to shield you from accidental splashes. Wearing the proper gloves is extremely important. Choose them according to the hazards of the particular experiment you're running. If you have questions, consult the MSDS. Check with your supervisor about air purifying respirators. If your work demands one, it's important that you be properly trained and fit tested. An improperly fitting respirator will not protect you. Self-contained breathing apparatus, or SCBAs, are sophisticated pieces of equipment. Do not put one on unless you've been instructed in their use. Wear sensible shoes in the lab. No open toes. Closed leather shoes keep spilled chemicals off your feet. Many labs require safety shoes. Check all personal protective equipment before using it. If PPE is cracked or worn, its effectiveness is in question. Discard it. Remove your lab coat and gloves before leaving the lab area. And wash your hands. No sense taking any contamination with you. Check each piece of equipment before setting it up. Everything must be clean and in proper working order. Glassware that is chipped or cracked absolutely must be replaced. Any amount of pressure could shatter it. If your procedure requires specialized equipment or containers, find them. Makeshift substitutes could be dangerous, and they're no solution. Work to keep your lab clean and clutter-free. Report and correct any unsafe conditions or actions. Misplaced equipment or furniture can cause trips and falls. Move it to a more suitable area. Utilize local ventilation controls such as lab hoods. When used correctly, the airflow within an exhaust hood effectively confines and removes released vapors. Test hoods to make certain the airflow is operating correctly. There are many types of lab hoods. Select the right one for the procedures you're working on. Biological safety cabinets confine any potentially infectious aerosols which are created, but might not be appropriate for chemicals. Work at least 6 inches inside the hood. An invisible air curtain keeps vapors from escaping under the sash. Keep the sash as low as possible. Never interfere with the airflow. This will reduce the hood's effectiveness at eliminating vapors, allowing contaminated air in your breathing zone.
Proper storage of chemicals is very important. Try not to store them in a hood or on workbenches. Containers are too easy to knock over and are unprotected from accidental fire.
Collect small quantities of flammables in UL-listed containers with spring-loaded caps. Place amounts greater than 1 liter in flammable storage cabinets and remember to lock the door. Regulations exist for the safe use of compressed gas cylinders. They should be located away from any sources of flames or sparks. Strap cylinders to benches so they won't fall and hoses won't rip free. Ask your supervisor about the number of flammable cylinders which can be safely stored in your lab. Each chemical container must be correctly labeled so that anyone who happens upon the container will be sure to know what's in it. ACN may spell acrylonitrile to you, a potent carcinogen, but to someone from outside your lab, ACN may be confused with acetonitrile, a common solvent. Correct labeling means safety. Writing out the proper name of a substance will allow others to locate the proper MSDS forms. Some experimental compounds we work with may never have a written MSDS. This does not mean that there isn't a hazard. Take all the necessary precautions. Unauthorized experimentation, though, is never permitted. If an accident occurred and you weren't in the lab, who would know how to handle it? Your company has a written policy on handling chemical and infectious waste. Plan for the disposal of this waste before you begin your experiment. A mistaken disposal could cause severe problems to public health and the environment. It could have harsh criminal and civil implications. Ask your supervisor or safety professional if you have questions on disposal. In case of an accident, you should know what to do. Know your facility's emergency procedures. You may need to dial 911 or alert on-site emergency responders. Learn every step of evacuation routes. It's important to know what areas these routes will take you through. Talk to your instructor about emergency systems and fire alarms. Knowing the location of emergency equipment is also important. But if you don't know how to use fire extinguishers, don't make an attempt. Remember, life over property. You should know what to do if there's a spill of the chemicals you're working with. If it's a flammable substance, turn off all sources of ignition. Know the correct cleanup procedures for the chemical you're working with. Evacuation may even be called for. Know the locations of eye washes and safety showers, as well as their effective use. In case of a chemical contact, remember to flush for at least 15 minutes, then report the incident and call for medical help.
Coming into a new lab can be stressful, as well as exciting. There's new materials, new procedures to learn, new people to meet. This may even be your first job. Don't make it harder for yourself to adapt. Where safety is concerned, do your best up front where it does the most good.